So good morning, dear students. Hope I am audible.
Yeah, sir. Very good morning, sir.
Good morning, Arpita. So 10 o'clock right now. We'll start our class. Okay. I'm sharing my screen. Okay, right. Okay. So good morning, one and all. Today we'll discuss the last topic of module 3, that is voluntary computing. Voluntary computing is one of the powerful technique. Still it is in use in America. So we'll discuss how this voluntary computing is associated with MapReduce, and why India is not powerful country. Okay, so in terms of computation, distributed computing, we'll see why America is called a powerful country in distributed computing. We'll discuss that. Okay. The class agenda would be on voluntary computing, discussing on voluntary computing. At the end of the class, Anushruta will take. Anushruta, are you there? Anushruta?
Yes, sir. Yes, sir.
Yeah. So at the end of the class, it will be handed over to you. Screen you can take out.
Okay, sir.
Okay, ma'am. Thank you. Right. That's about voluntary computing. And voluntary computing is a type of distributed computing. It's a type of distributed computing. So computing happens at various places simultaneously, parallelly. An arrangement in which people, so-called volunteers, provide computing resources to the projects which use resources to do distributed computing or for storage purpose. Thus, the computer owners or users donate their computing resources to one or more projects. This is very popular. See, America does lot of research projects, and for all those research projects, America don't want to invest on computers. America don't want to invest on various supercomputers or automated systems. What they do, they ask their country citizens to switch on their laptops and computers during nighttime and sleep. So during nighttime when the computer is on, so computer will be used by the server for the projects. So, and each computer will be connected to internet. Of course, internet is very common there. Just like we have electricity in each house, internet is also available in America. And they use those computers for distributed computing, for computing various projects. Maybe doing some biological research, analyzing some graphics, that is computation, graphics computation using the satellite computation. Certainly it works. So it is just like that. So they don't want to invest on a lot of components, computing components, because people already have. When people are not using, of course, they can voluntarily give the resources. The computer, the server, main server will send the computational component to the citizen's computer, and citizen's computer will process it, and it will give the results back. So this is a architecture. So look at this voluntary computing. So voluntary computing, you have a voluntary node, so which will request for some this one. And what happens? So this bionic we call it as, this is a server that generally had a lot of data. So what happens, it will say through internet they are connected. So what happens, it will connect to all voluntary nodes. Voluntary nodes, certainly whenever you want to contribute some data, contribute your computational resources to this voluntary system. So what you have to do, your computer has to request for a work unit, and what happens, the server will download the input file, your computer will compute, and the final result will be uploaded automatically. Everything is automated. Only thing is you have to just send a request, that's all. My computer is ready for doing some processing. So, and of course security issues, everything will be taken care by the server. Automatically this computing happens. And in many projects, for working like this, they pay rent to the owners, that is voluntary nodes. They'll pay rent. So just for using their computers, entire evening, night. So automatically what happens, their computers are being paid hourly basis. So per hour they'll pay, I think, $1 or something. So $12, $10 they'll get as an income. Just if you have a computer at home, so your computer will earn $10. So voluntary computing project work by breaking the problem. They are trying to solve into number of small chunks called work units, and these work units are sent to the computers around the world, and they analyze, and finally, so it is sent through internet, and it will be analyzed. The final results will be received back. So this is how the voluntary computing works. See, there is only one server is working. There is only one server working, and that server is making all the workstation voluntary nodes to work, and finally the results used to be brought back to the server. So by the time you wake up in the morning, your entire analysis done, work process is done, and of course, so entire satellite analysis, everything it is done. Even NASA it is using. So this is how it works, voluntary computing. There is one very popular example, SETI at home. SETI at home is also a similar kind of thing. So to analyze the satellite images, so to analyze uh, biological gene, so they certainly use this computers, and they take the renting, they take the computing resources for rent, and they'll pay for that particular rent. So it is just like that. SETI at home is an internet-based public voluntary computing project employed in Bionic software platform created by Berkeley SETI Research Center, and it is hosted by Space Science Laboratory, University of California, Berkeley. So it has been, this is a project. So they want, the university want a lot of computers to work, but they don't want to invest on computers. What they do, they rent all these computers. They ask for voluntary computers. So people will give computers voluntarily, their computing resources, and all those computing resources are being utilized through internet. It will be processed, and the results will be sent back. And of course, you observe, it sends the work unit of 0.35 MB of radio telescope data, and takes hours, days to analyze on a typical home computer. When the analysis is completed, the results are sent back to the server. Automatically, it is sent back. So your computer will download, analyze, and send the results back. Computer program will be running automatically. So like this, it is one example at one home, one computer. Like that, so many homes. So this project is running. So that's why this project, SETI project at home, it is running at home. So many homes will support this. So this is how Americans, they make use of even citizens' computer also. I think in India, if this project is done, I think we have very powerful computing resources. All those computing resources can be utilized and analysis whatever the task that we want to do. It can be done within no time. So this is one of the very good example. SETI, search for extraterrestrial intelligence. It is called SETI. SETI full form is search for extraterrestrial intelligence. Runs a project called SETI at Home, in which volunteers donate CPU time from their homes. Otherwise, computers are idle to analyze the radio telescope data signals that are coming from satellites, the scenes of intelligent life outside the earth. They just want to know, analyze outside the earth. They want to just analyze it. So like this, they certainly use this. And other projects include Great Internet Mersenne Prime Search. So this is also another project just like SETI at Home to search for a large prime numbers and foldings at home. So this is also another problem, another such project to understand the protein foldings and how they are related to diseases. So just to find that, they make use of this various computing resources across computer. So they will not be even knowing their computer is doing wonderful job, but it has been done so well coordinated. Voluntary computing project works by breaking the problem they are trying to solve into chunks, which is called workloads, that are sent to the computer around the world for analysis. And example is SETI at Home. Certainly, this will be sent 0.35 MB of radio telescope data, and takes hours, days to analyze the on a typical home computer. And finally, once it is done, the results are sent back to the server. And as a precaution to combat cheating, each work unit is sent to 3 different missions, and needs to at least 2 results to agree to accept. So just to get correctness of the processing, it will be sent to 3 computers, and the results from 3 computers are compared, and the best result will be taken. So it's just like that. Okay, so they'll be doing, and of course, the current statistics. Actually, SETI at Home started in 1999. So it started in 1999. The project goal is to discover radio evidence of extraterrestrial life. So beyond Earth, is there any radio frequency waves in the space? They just want to analyze. And for analysis, they use lot of satellites, and all these satellites send lot of sensor data, and this data will be stored, it will be analyzed. If there is any signal strength, automatically that processing has to trigger the what do you call the message to the appropriate persons. So this is, and the total number of users is around 18 crore 3 lakh 18 lakhs 3,000 18 lakhs plus users in March 2000. Active users 91,000, and active hosts is almost 1 lakh 44,000 computers are involved. And so if you do this voluntary surveys, you'll also get rewarding certificate from them, so stating that this you have done. See, Ariel is a person who got contributed to his project, and his computer is serving the project since 1999, August 1999. So, and it will be, they will have a certificate also like this. And this certificate, certainly based on the certificate, so they can avail some, citizen privileges in US. So it is just like that. That's why the country has so much of powerful computing components. So this project, this kind of projects that should happen in India also, I wish. And how voluntary computing is different from MapReduce. That's fantastic. So MapReduce also works similar way, breaking the problem into independent pieces of work, and each work is assigned to various data nodes for processing, and finally the results are brought back. So voluntary computing problem is very CPU intensive, which makes it suitable for running hundreds and thousands of computers across the world, because the time it transfers the work unit is drafted by time to run the computation time. Every time, whenever you want to compile, every time you want to analyze what happens, the data from the server, it will be sent to the the computer, and computer will start analyzing. Whereas in MapReduce, it is not like that. Data will not be moved, only programs are moved. So that is another point. Volunteers are donating CPU cycles, not the bandwidth. They never, contribute the bandwidth. They cannot contribute. So volunteers can only give their CPU. That's all. CPU cycle memory. MapReduce is designed to run jobs that last minutes or hours on trust. Dedicated hardware running on a single data center with a very high aggregatable bandwidth, interconnects. So, of course, there are interconnecting many computers, so that are taken place in this analysis process. That takes place in analysis process, and of course. So they are more worried about data movement bandwidth. So they never move the data. They move the programs itself for efficient execution of the program. And of course, it is clear that voluntary computing runs perpetual computation on untrusted machines and on internet with a high variable connection speeds, but there is no data locality. So this is very important to understand. So voluntary computing is totally working on perpetual computation. Perpetual computation means which is not fixed computing. So today people may give 100 computers. Tomorrow those 100 computers may not come as volunteers. You'll get only 10 computers. The day after, tomorrow you'll get some other set of computers. So like this, what happens? Lot of so lot of lot of computation happens, and these the computations are certainly look for untrusted. They are working on untrusted environment. There is no trust. There is no fixed. There is no proper internet. There will be internet will be highly variable. So internet is very much highly variable, and there is no data locality. Data will be located in different places. So of course, it is very difficult to trace. So that's the comparison study that we make with MapReduce and voluntary computing. Probably in the next class, we'll do a quick revision of module 1 and module 2, module 3, and we'll announce a test. Okay, there is an announcement of internal test. So probably this by Saturday, all of you should take internal test. You have to write internal test for 1 hour. So I think it will be online test. So online test will be scheduled. The details of the online test we will notify you very shortly. And uh, that's all for today. And I have some. I have just referred some of the this one, assignments. And let me see some of the assignments which I have noted. Some of the common problems that we find it. I saw Wagish has sent. Wagish, are you there? Wagish, are you present in the class? See, Vagish, he has written in blue pen and it is not so legibly visible. So whenever you are writing and scanning, better you scan using black pen. So I suggest you to go with write in black pen. Even how you are writing in examination, you're writing in a black pen, and it will be executing. It will be scanned. It will be scanned, and it will be totally easy to read. So visibility is more when you write in black pen. So let me see Vinuta B. Vinuta's assignment. Vinuta, she has written in black pen. Okay, it's clearly visible. You can see it's clearly visible. She has written okay, like this. So I expect you to see on the top. She has written USN. So every page should have USN. Every page should. So every page means both the sides. First page, second page. Second page is she has missed. Actually, this is the third page, and it has to be written. And one common observation when you are solving this outlier detection, you are writing this Z score. Once you know the Z score of each one, there is a concept called if the Z score crosses beyond the threshold. So threshold is 3. Threshold is 3. So if Z score crosses 3, or if threshold crosses 2, maybe 2, if I take 2, so what happens? ID number 6, the Z score is plus 4. ID number 5, plus 2. ID number 3, minus 3. So these will come, these are the outliers. ID number 3, 5, 6 are outliers. So that is missing in this assignment. At the end of the problem, you have to write, since the threshold Z score is 3, that is the modulus of Z score of 6 is more than 3, or more than 2, sorry, threshold is 2, more than 2, 5 is also more than 2, 3 is also minus 3, that is minus 3. If you modulo, if you do absolute value, it is 3. So 2 is the threshold, and 3 will be the more than. So these three, the values, minus 3, plus 2, minus 4, they come, they crosses the threshold. So ID number 6, ID number 5, ID number 6, ID number 5, and ID number 3, these are the outliers. You can certainly write, these are the outliers. You can certainly write, therefore you can certainly write therefore ID 3, 5, and 6 are outliers. They are outliers. You have to write this. You have to write this. And once you write this, your answer is completed. So if you write like this in the examination, what happens? You may lose 1 mark or 2 mark. So final answer is you have to find the outliers. Outlier you are going to find based on the Z score. If the Z score is beyond 3, so then you can consider. So if you consider beyond 3, certainly what happens? This 2 will not come. Yes, 2 will not come, and ID number 3 and 6. ID number 3 and 6 becomes the outliers. So It is just like that. So you can find it out like this. So this is one thing that most of the students, they have not written this. So I want everybody to write based on the z-score value. You have to write outliers. What are the outliers? So that's all for today's class. Now it is over to Anushruta. Anushruta will talk on Hadoop ecosystem, different components of Hadoop ecosystem. So I stop sharing the screen. Anushruta, it is over to you. Anushruta, please take. It is over to you. Yeah, we could able to see Anushruta. Your voice, you are talking on mute. Kindly unmute it. Anushruta, please unmute. We can't hear you.
Sir, am I audible, sir?
Yeah. Now you are audible. Yes. Please go ahead.
So good morning all. In this
You have
session,
10
let us
minutes.
try to
You have 10
explore.
minutes on your account. So the clock is running.
Okay, sir. I'll finish it off by 10 minutes, sir.
Yeah.
Okay, good morning all. In this session, let us try to explore Hadoop ecosystem. The success of Hadoop framework led to the development of array of related softwares. Hadoop ecosystem is neither a language nor a service. It is a platform or a framework which solves big data problems. Main purpose of these software is to enhance the functionality and increase the efficiency of the Hadoop framework. Hadoop with these set of softwares makes up the Hadoop ecosystem. So these are the various components of Hadoop ecosystem, that is HDFS, MapReduce, Hive, Pig, HBase, Hue, Woozy, Spark, Cloudera Search, Impala, Flume, and Scoop. As MapReduce is already explained by Sir and HDFS is already explained by our friend Arpita, I'm not going to explain about those two components. Let us see the remaining components. So what stores the data in HDFS? It is HBase. It is a NoSQL database or non-relational database, mainly used when we need a random real-time read or write access to our big data. HBase provides support of high volume of data and high throughput. Throughput means the transfer of data from one location to another location within a given amount of time. HBase is used in various platforms, that is e-commerce, medicals, sports, oil and petroleum, and web. HBase is used in medical field to store the patient details, storing the disease history and many others. In sports field for storing match histories for the better analysis and prediction. HBase is used to store the user history and preferences for the better customer predictions in web. So it is used in oil and petroleum industry to store the exploration data, predict the probable places where we can get oil, to store logs about the customers, to target better business in e-commerce. E-commerce means the application that we use, Amazon, Flipkarts, and etc. So one good example that can think of is we are all aware of COVID-19, that is Corona. Government needs to maintain the history of the patients who are all tested positive, who are all in the intensive care, who are all discharged, what is the death rate. For all these things, we can go for HBase. So now let us see how the data is ingested or transferred to HDFS. It is done by Scoop. As you can see in the figure, it is used to import the data from the relational database such as Oracle and MySQL to HDFS and export the data from HDFS to the relational database. So after the data is transferred into the HDFS, it should be processed. One of the framework that processes the data is Spark. Spark is an open source cluster computing framework. It supports machine learning, business intelligence, streaming and batch processing. It provides 100 times faster performance as compared to MapReduce. After the data is processed, it should be analyzed. It could be done by Apache Pig, Impala, and Hive. Pig is mainly used for data analytics. It converts the script to MapReduce code. Thus saving the users by writing complex code for MapReduce. We can also go for Impala. It is open source high performance SQL engine which runs on Hadoop cluster. Impala have very low latency. Latency means the state of existing but not yet being developed or manifest. It can be measured in terms of milliseconds. You can also use Hive to perform the data analytics. It is similar to Impala, preferred for data processing and ETL. ETL stands for extract, transform, load operations. It executes the query using MapReduce. So far, we have seen how the data is ingested, processed, and analyzed. So now the data is ready for the users to access. So what supports the search of data? Cloudera and Hue supports the search of data. It enables non-technical users to search and explore the data stored in Hadoop and HBase. Users do not need SQL or programming skills to use the Cloudera. It provides simple text area to search. Another one is Hue. Hue is the acronym for Hadoop User Experience. It is an open source web interface for the Hadoop. Operations performed by Hue are upload the data, browse the data, query a table in Hive and Impala, search the data. Hue provides SQL editors for Hive, Impala, MySQL, Oracle, and Spark. It makes the Hadoop easier to use. Not only Hue, but all these components makes the Hadoop easier to use. And to explain about all these components in depth, it requires more time. I'll just give you the overall view or the basics of these components. If you want to know in detail, you can go through these two links which I have referred. So that's all, sir. Thank you.
We should thank, Anushruta. It was a wonderful, talk presentation. You could able to finish it within your time. Thank you, Anushruta. So
Thank you, sir.
it was wonderful, really wonderful. Okay, the recorded, your entire class session is recorded, and it will be available in the YouTube channel. You can download and you can watch. See you until then. See you and have a wonderful day. See you tomorrow. Thank you.